Okay, guys, so we're going to go ahead and we're going to start with the second part of these problems, and we're going to go ahead and we're going to talk about the stoichiometry problem. So basically grams of one molecule to go ahead and to get into grams of another molecule. So we have a couple of things that I want to go over first. So first and foremost, right, we're going to be working with this equation right here. And going ahead and working with that equation, we're going to go ahead and we're going to start by balancing out this reaction. So you guys will see that on here, my nitrogens are balanced, my oxygens are balanced. The main thing that's not balanced, as you guys see right away, is my hydrogens. I have 3 hydrogens here and only 2 hydrogens there. So that is going to be the thing that I have to go ahead and I have to balance. And as a result, I'm going to have to balance some oxygens as well. I'm going to try to get this 3 and the 2 to kind of be like very close and similar numbers. So I'm going to try to get them both to 6 because 3 times 2 is 6, and that's going to be like my lowest common denominator. So I'm going to try a 3 here and a 2 here and look at how that changes my number. So now that I have a 2 here, that means that I only have 2 nitrogens. So I got to balance out my 2 nitrogens. Okay. So then last but not least, I'm going to go ahead, I'm going to balance out my oxygens. So I have 2, 3, I have, 2, 3, so I should have 5 oxygens here, right? And I have 2 oxygens there, right? And then that's not going to go well, right? So we are going to go ahead and we have to get this thing up a little bit higher. 2 times 3 is 6, 6, okay. So then we're going to go ahead and we're going to work through this again. So we're going to go ahead and we're going to increase the amount of hydrogens. So I'm going to go ahead, I'm going to try a 4. 4 won't work because 4 times 2 is 8 and nothing times 3 is 8. 4, 5, 10, no. I'll try 6 is 12. 4 is going to be there, and that would be 12. And then this will be 4. So then that should work a little bit better. So now I have 4 and 6, so now I have 10 oxygens there. So that would go ahead and that would give me a 5 in front of there. So again, a lot of these things are kind of like going ahead and kind of having like a trial and error like session and really be comfortable with that. So you guys will see that your nitrogens do have a high, your nitrogens like were balanced at the beginning, but it's really came down to going ahead and balancing out those nitrogens and making sure that everything else balanced out, and nitrogen also like balanced out as well. So now that we have our equation going, we're going to go ahead and we can actually start working on our problem. Right, so it says if we go ahead and if we start with 40 grams of O2, so I'm going to go ahead, I'm going to write my 40 grams of O2. I need to go ahead and I need to find the limiting reagent. Now you guys will notice right away that it does not tell me, right, what to go ahead and to solve for, right? So in this case, I can pick anything on this side. I can pick NO or I can pick H2O, right? But whatever I pick, right, that's going to be the thing that I have to have in my answer. So whether I want grams of H2O, right, I need grams of H2O for both of them. Right. So when it just says find the limiting reagent, it's going to be up to you to go ahead and to pick which one you want to do. Okay. So I'm going to do water for both of them because I know that one like straight off the bat. And then we will kind of go ahead and we'll go from there. Okay. So the first thing that I'm going to do is I'm going to go from grams to moles. And again, right, a big reason why we are going ahead and why we're traveling through this is that if you guys go ahead and if you guys refer back to this map, right, we're starting like out here, we're starting with our mass in grams, and we have to get all the way to something else in mass in grams, right, so that we can go ahead and we can compare. So in order to do that, right, I'm going to go moles of A, and then I'm going to do the mole ratio. Then I'll get moles of B, and then I'm going to go all the way to mass in grams. So that's going to kind of be like the path that I'm going ahead and that I'm going to be following. So you guys will see that I have 1, 2, 3 conversions that I have to do. So I am going to get to work on those 3 conversions, and then we will talk about some of these things a little bit more. Okay, so going back to my study guide, you guys will see that I start with 40 grams of O2. I'm going to go to moles of O2, right? So 1 mole of O2, right? And oxygen, oxygen is 16. 2 oxygens are going to be 32 grams of O2, right? And then I'm going to go ahead and I'm going to do my next step. So I'm going to go ahead and do my mole ratio. And since I'm going to H2O, right, I'm going to have moles of H2O on top, and I'm going to have a mole of O2 at the bottom. Then I'm going to go ahead and I'm going to use my mole ratio, right? And again, your mole ratio is to switch, right, from one type of molecule to another type of molecule, right? So I would have 6 moles of H2O, and that's going to be the same 6 that goes there. And then my moles of O2, I'm going to go ahead, I'm going to get that right there. So right there, it should be 5. So I should get that 5 moles of O2, and that comes straight from the balanced equation. So your mole ratio comes straight from your balanced equation. Now that I have moles of O2, H2O, I'm going to go ahead, I'm going to convert that to grams. So 1 mole of H2O is 18 grams of H2O, right? And now everything's set up, right, because I want my limiting reagent in grams. And then you guys would go ahead and you would multiply and divide across. So you go 40 times 6 times 18. And then you should get 4320 over 32 times 5, which is 160, right? So 4320 divided by 160 should be 27 grams of H2O. So then that's what you guys would get for your first one. And again, right, for these limiting reactant problems, you really want to get to a point in which you guys can compare and contrast, and you want to compare like apples to apples, right? So you want to get the other one to grams as well. So I'm going to go ahead, I'm going to get my 50 grams of NH3, right? And then I'm going to go ahead, I'm going to get 50 grams to moles, right, of NH3. And since I'm using grams, I have to figure out how much NH3 weighs, right? So nitrogen's 14 plus 3 would be 17, right? So this would be 17 grams of NH3 in 1 mole, right? Then I'm going to go ahead, I'm going to do the same thing. I'm going to use a mole ratio. So I want to go again to H2O. So I'm going to have mole of H2O. And I'm going to take that 6 that's right in front of that balanced equation. And then I'm going to get moles of NH3. So this should be a 4 moles of NH3. My bad. And then after you guys go ahead and after you guys do that, you guys are going to go and do the same thing. You're going to get grams of H2O. Right? So now you guys are going to go ahead and you guys are going to multiply and divide across. So let's go ahead and let's multiply and divide across. So 50 times 6 times 18. And then that is 5400. And then 17 times 4, which is 68. So that's going to be a really high number, which will be 79.41 grams of H2O. Right. So then for my limiting reagent, what I'm going to do is I'm going to compare and contrast my 2 answers. So which one's higher, which one's lower, right? So you guys will see that this one right here, that 27, is a lower than 79. So my limiting reagent would be, in this case, oxygen gas, which is O2, right? So that would be like my first one. Okay. My next one, same deal. I'm going to go ahead. I'm going to start by balancing out this equation. Since I have lots of hydrogens and oxygens, I'm going to go ahead. I'm going to make sure that I list these things out for you guys, and then we will go ahead and we'll keep working through these problems. So I have, let me list them down the middle. I have C, I have H, and I have O, right? I have one C on both sides. I have 4 hydrogens on this side, 2 hydrogens on this side. I have 3 oxygens, and I have 3 oxygens. So the big thing that I have to balance out is my hydrogens. So I go ahead and I'm going to go 2 H2Os. And since I have that, it goes ahead and this changes to 4. And then this number up here is also going to change, right? So I have 3, 4 now. So now I have 4. So then I have to go ahead and I have to fix this side, right? So now I have 3. I'm going to have 4. So I'm going to go ahead and I'm going to have to add more oxygens on here. So we are going to go ahead and we're going to try this. So I'm going to go ahead, I'm going to put a 2 in front of there so that my numbers can kind of even out. But as a result, I am going to have to add more oxygens, but that would be a lot simpler than going ahead and trying to do something big on here. Okay, so because of this, I'm going to have to put a 2 in front of there, right? So I have 2 carbons on both sides. I have 6, 7, 8 hydrogens. And right now I have 4, so this number is going to change. And then I have 2, 3, 4 oxygens, right? So now I'm going to go ahead, I'm going to see if I can balance this thing out. 2, 3, so I have 4 here, and I don't know how many I'm going to have here, but I need 8, so I need 4 here. So I have 8, and then this would be 8. Right? So now I can go ahead and I can add a 2 in front of here. And then this would be a version of a balanced equation. Another possible answer would be to just go ahead and to make sure that you have your 1, 1, 1, 2 would be another possible one. So I am going to go ahead and let me double check this real quick. 4 times 2 is 8. So this is 8. Then 2 times 2 is 4. 5, 6. Uh-oh. This does not balance. Hold up. Give me 1 second. There's something up with my oxygens. Okay. And this is okay because this actually happens. Right? So I have 8 on this side. I need to get 8 on this side. I currently have 2, 4. Right? So I need 2, so I need a 3 here. That's what it is. Yeah, so 3 times 2 is 6, 7, 8. Yes. Okay, so now it's 8. Okay. So your numbers would be 2, 3, 2, and 4. So that would be your numbers on here. Now that you have your equation balanced, now you can start the problem. Okay, so going ahead and looking at this, right, you guys are going to go ahead and you guys start off with your limiting reagent, and we're going to start with 48 grams of O2. And the first thing that we're going to do is that we're going to convert that to moles. So 32 grams of O2 in 1 mole of O2. And again, I get these 32 grams from the periodic table, 16 and 16, right? And that's how you get that. And then I'm going to go ahead, I'm going to use my mole ratio so that I can go ahead and I can pick which one is my limiting reagent. And again, I'm going to look for H2O. I already have it on the top, right? I've already solved for it, right? So I'm going to go ahead. I'm going to do H2O. So there is 4 moles of H2O for every 3 moles of O2, right? Then I do 18 grams of H2O is in 1 mole of H2O, right? And again, I add 18 because I'm going ahead and I'm adding, right? Oxygen weighs 16, hydrogen weighs 1 each, right? And I should get 18. Then I'm going to multiply and divide across. So I'm going to go 48 times 4 times 18, right? And you guys should get 3, 4, 5, 6 divided by 32 times 3, which is 96. So 3, 4, 5, 6 divided by 96 should be 36 grams of H2O. So that is what you guys should get as your answer. Then we're going to do the same thing for 60 grams. Right, so then you should have 1 mole. Oh, shoot. Wrong molecule. I was like, why did that look wrong? CH3OH. Right, then I should have 1 mole of CH3OH. And then I'm going to go ahead, I'm going to add those things together. So 16 from my oxygen plus 4 plus 12 should be 32 grams of CH3OH, right? Then I'm going to go ahead, I'm going to again use my mole ratio so I can switch my CH3OH to H2O, right? So I'm going to have 4 mole of H2O over 2 mole of CH3OH, right? And then I'm going to go ahead, I'm going to make sure that I get that mole conversion going. Right, and then I'm going to multiply and divide across. So 60 times 4 times 18. So 60 times 4 times 18, which is going to be 4320, divided by 32 times 2, should be 64. So 4320 divided by 64, which is going to be 67.5 grams of H2O, right? So then you would go ahead and you look at which answer is smaller, right? And I see that this 36 grams is smaller. So that means my limiting reagent in this case is going to be my oxygen again. And again, right, to go ahead and to figure out what you are solving for when it's asking what is the limiting reagent, you can pick, right? So some of you guys might have done CO2 instead, right? It would be the same deal, right? Except that some of these numbers in your mole ratio would change, right? But as long as you go ahead and you follow these steps, that should work, right? And it's the same thing for the problem above. As long as you guys follow the steps, then you guys should be good with this, right? So for the last one, I'm just going to go ahead. I'm going to just set it up for you guys, and then you guys should be able to solve this one on your own. So we're going to go ahead and we start with 35 grams of O2. And it's a very similar setup, right? So we're going to have to go grams to moles of O2. Then you get moles of whatever you want, which is SO3. And then you get moles of O2, right? And then you go grams, Then you're going to go grams of SO3 over moles of SO3. And then you guys would go ahead and you guys would solve it, right? And the same thing with S8. You start off with 40 grams of SO3, is S8, my bad. You start off with 40 grams of S8, and then you do the same thing. You would have moles of S8 over grams of S8. and then you would do the mole ratio. So then you would do the mole of S8. Oh no, my bad. It would be the moles of SO3 over the moles of S8. And then you go grams of SO3 over moles of SO3. And then you multiply and divide across. And then again, whatever is your smaller answer, right, that is going to be your limiting reagent. Okay, you guys, so good luck with your test tomorrow. And then if you guys have any questions, make sure that you guys contact me.